Hi, this is Maggie. In this video, we're going to talk about conditional execution in Python. We will talk about different forms of the if statement as well as relational operators. This program calculates the angle between evenly spaced stars in a circle. It obtains the number of stars from the user, referenced by the variable num_stars, and then divides the number of degrees in a circle by num_stars. We'll have a problem, though, if the user enters 0, because division by 0 is undefined and raises an exception in Python. I'll run the program and enter 0 so you can see the exception. We can avoid that with an if statement. Let's only calculate the angle if the user gives us a value that is greater than 0, since a negative number of stars simply doesn't make sense. I will write if num_stars greater than 0, colon, and notice that if turns orange. Remember that idle will turn Python keywords orange. Also remember that Python is case sensitive, so I want to be sure to type that as lowercase I, lowercase f. I need to put a colon after my condition, num_stars greater than 0. And then I indent the code that should execute if the condition is true. I will only calculate this angle and display the result if this is true, so I'll indent the rest of the code. Let me patch up my comment too to describe the new code. I'll write calculate the angle between the stars if greater than 0. Now I'll run that and enter 0. And you can see the code did not cause an exception to be raised because I avoided the division. So, what does the if do? Remember that code executes sequentially by default, or top to bottom in the file. The if statement is a sort of timeout. Timeout, we need to check this condition, and if the condition evaluates to true, so if the value referenced by num_stars is greater than 0 in this case, then the indented code will execute. And then when it is done, we resume execution with code indented at the same level as the if statement. We don't have any code like that. The program finishes either at the test if it's false, or at the end of the conditional code if it's true. This is a branching execution rather than a straight line. We have only one branch, but let's look at how to make more than one branch. Right now the program ends abruptly if the user enters a value less than or equal to 0. We can make this into two branches, one that executes if the condition is true, and one that executes if the condition is false, by putting an else after the conditional if code. The else will be indented at the same level as its matching if, and these statements are all part of one larger compound statement. They go together. So I'll type else, followed by a colon, and when I press enter, notice that idle automatically indents for me. This will be the other branch, the code that executes if the condition is false. And I'll just write an error message, something like the number of stars must be a positive integer. Users love hearing about integers. Now, when there's the timeout to check the condition, either the if code executes or the else code executes. One or the other will always execute based on whether the condition is true, if code, or false, else code. Let's run it one more time with that input of 0. And you can see we get the error message in the else. Now let's focus on that condition. How do we write conditions? What operators are available to us? what do they mean? We have 6 relational operators that we can use for comparing numeric data or string data. Let's focus on numeric data and use a number line to show when each expression is true or false. I've drawn a number line here and arbitrarily marked the value 10. We'll create expressions using the relational operators and show when they're true using the number line. Let's begin with greater than, the operator from our program, and we'll use a variable called x. The expression x is greater than 10 is true for all values of x that are greater than 10 or to the right of 10 on the number line. The open circle over the 10 indicates that 10 is not included in the set of values. If x were 10, the expression would evaluate to false. Now let's look at the expression x greater than or equal to 10, which is written with the operator greater than or equal, a greater than sign followed by an equal sign with no space between them. The circle over the 10 is filled in because 10 is included in the set of values for which this expression will evaluate to true. This expression is true for x equal to 10, or any value of x greater than 10 or to the right on the number line. Less than and less than or equals are similar. For x less than 10, we have an open circle over the 10 because it is not included in the set of values for which this expression is true. But for x less than or equal to 10, written as a less than sign followed by an equal sign, with no space between, 10 is included in the set of values for which this expression is true. Now there are 2 more operators. The first is equal to. I have x equals 10 here. The test for equality is written with 2 equal signs with no space between them. Beginner programmers, and sometimes even experienced programmers, sometimes mix up the test for equality, which is 2 equal signs, with the assignment statement, which is 1. Python won't let you make that mistake, fortunately. So this is true only when x is 10 and for no other value, so I have a filled circle over 10. The final operator is not equals, and that is written as an exclamation point equals sign with no space between. X not equal to 10 will evaluate to true for all values that are not 10, so I've drawn an open circle over the 10 and lines extending in both directions. Now that we can write a variety of expressions, let's look at another form of the if statement in Python. This if statement is an if, elif, else, and it allows you to create a multi-branch structure. You will write code with a multi-branch structure if you have mutually exclusive situations that you want to handle differently. Suppose we want to categorize the daily intake of a nutrient as low, ideal, acceptable, and high. Any value below 500 is categorized as low. Ideal is a value 500 or greater but less than 1500. Acceptable is a value 1500 or greater but less than 2300. And any value 2300 or higher is categorized as high. I'm keeping the nutrient in units as intentionally vague. Our focus is on categorizing the ranges of values. I've written a program to do this using the if, elif, else structure. Take a moment to read it over, perhaps pausing the video. So I'm obtaining the nutrient from the user, and then I write if nutrient less than 500. This is our low categorization. I am ignoring inputs that make no sense, such as negative inputs, and just categorizing them as too low. The indented line under this is a print statement that informs the user their nutrient intake is in the low category. Now, at the same indentation level as the if, I have an elif statement followed by a condition. I can have as many elif statements as I need. Here I have 2. The elif is always followed by a condition and then a colon. The test for the first elif is nutrient less than 1500, and the indented code reports the ideal category. The test for the second elif is nutrient less than 2300, and the indented code reports the acceptable category. Finally, I have an else, and the indented code reports the high category. This is all one compound statement, the if, the 2 elifs, and the else statement together. Only one of the indented lines of code will execute. Now I can have as many indented lines as I need. I have only one under each condition, but I could have more. The form of this statement must be if, then 0 or more elifs, and then 0 or 1 else. They are always in that order, but you do not have to have elifs or the else. You could have elifs without the else without the elifs, as we have seen, or just an if alone, no elifs or else. Suppose the user types in a value for nutrient that is 2500. The first test will execute, nutrient less than 500. That will be false. So the next test will execute, nutrient less than 1500. That is also false. So the next test will execute, nutrient less than 2300. This is also false. So the else conditional code, the else indented code, will execute. As soon as a test that evaluates to true is found, however, the rest of the statement is bypassed. So if the user enters 300 for the value for nutrient, the first print statement will execute, and the rest of the code in the statement, the elifs and the else, will be skipped. This is an efficient way to test mutually exclusive cases and execute code for only one case. I recommend you practice writing expressions with the relational operators and practice writing conditional code and test it thoroughly by testing values in the full range of inputs. For example, what will this program print if the user enters 1500? It is easy to write conditional code that mostly works, but it is also easy to miss edge cases and write code that seems to mostly work but is sometimes wrong. Once we disrupt the flow of control with a statement such as if, we open a whole new domain of errors that we can write into our programs. Once you have learned to thoroughly test conditional statements, you're ready to move on.